Okay, so if I gave you this 2 comma 7 and I said this is the ages that my I like to start small businesses. One of them I thought about starting was a daycare. Because do you know how much daycare costs now? It is so expensive. And I was thinking, man, if we're going to be watching our own kids, my wife was staying home and watching our kids, we should just get like 6 extra kids and have her watch all of those kids. And she could make tons of money doing that. But there are some complications. Like you got to get licensed if you're going to have a daycare. You can't just like, I mean, you can babysit somebody's kids, but like if it's going to be a paid relationship, well, you might have a rule that you can go between 2 and 7 with a bracket on the 7. What does that mean? Can you take 2-year-olds? According to what I just wrote, can you take 2-year-olds? No. Can you take somebody who's more than 2? Yes, up until 7. And can you take 7-year-olds? Yes. Now there's actually a special license you have to have daycare for really little babies. Do you get that they have like, special needs because they're so tiny? And so they make you get special training if you're going to have a daycare for really little babies. So this could be your list of kids you can take at your daycare. And if you're making $20,000 a kid, now that might be a little high, okay, but let's call it $15,000 per kid. That's actually pretty realistic. And you have 6 kids come to your house for care. Can you do that in your head? How much would you be making?
630,000.
No, not 630,000. It'd be 90,000, though. Yep. You know how much a teacher makes? Between 40 and 100. If they're a new teacher, it's like 40. My point is, you make double a new teacher. All right, I'm not saying you all should start your own daycare. I'm just saying there's some money in that. Holy cow. But you'd have to get licensed, and there's all these rules about you can't have more than this many babies, which I understand. Like, it'd be wrong if you had, I'm going to take 15 babies in, and you can't take care of 15 babies. One of them's going to probably choke to death while you're busy changing a diaper or whatever. So anyways, moral of the story is you have to understand these, and you have to understand the difference between that and that. And I try to tell you these problems in the context of a real world to make it more interesting. All right, so if my domain for something was negative infinity to infinity, that means it goes forever from left to right. Does that make sense to you? Can somebody explain why we'll never have a bracket on an infinity? Because you can't touch it. Good enough. And I appreciate the hands, but that was a quick enough one. I'll just take an answer. Range. Let's say I said from 2 to negative 3. I guarantee it's wrong. It has to be wrong. I don't even care what the graph looks like. It's wrong. Why? Yeah, you can't have the smaller number has to be first. You could never have that answer because the answers always have to have the smaller number here. Do you get how this is an impossible answer? It's written in a way that just doesn't make sense. Okay. Next one I gave you was if you had an X and it was between 2 things, they'll always be less than signs. Always, always. Okay. Because if you were to go between 3 and 5, it'll just make sense between 3 and 5, and it's like that. The X is between them, right? But if you do it the other way with greater than signs, terrible things happen. It just doesn't make sense. So always use less than's. Okay. If I give you this graph, you should be able to tell me its domain and its range. If I tell you that's the point -1, -3, and that's the point 7, 7, it's open here, it's filled in there. Tell me the domain, tell me the range. We're just reviewing yesterday right now. Make sure you got all those little fine points. All right, domain is the X's. -1 to 7. Now
On purpose, I didn't put parentheses and brackets because I'm just thinking this through. This one, it's filled in, so it touches -1. Bracket. This one's empty. It's not touching the 7, parentheses. That make sense so far? Okay. Range is how low to how high. The lowest it goes is -3, but it touches it. And the highest it goes is 7, doesn't touch it. Bracket, parentheses. That one makes sense to you? All right, then there was one more from last night's that was really rough, and it was, you've got this graph, and then they ask you what's the domain and range of that. Let's talk it through, because I would bet you money, since this is the tricky one, and you're in honors, that this one will come up again, maybe on a test or a quiz someday. All right. It's kind of a trick question, because how far to the left does it go? It goes forever to the left, which is -infinity, and that is correct way to start. But the trap is to think, oh, and it also goes to the right forever, and it's +infinity. And the problem is that implies that this function is always working, that the function exists between -infinity and infinity, but there's a spot where it doesn't exist. Where doesn't it exist? 0. So you can't say that this function exists everywhere from the left to the right. So how do you say everywhere but 0? It'd be so nice if you could just say except not 0, but you can't. But if you think about what I'm writing here, you'll see that I'm writing it in a way that tells you it can't be 0. See, I put it to 0, and then I say it, parenthesis around it. See? Can't be 0. And then, this is just a U, lowercase, because why? Because we always use lowercase letters when you're typing things into Schoology. Always use lowercase, never have spaces. Okay? And then, it starts up again, not working at 0, but going to +infinity. That's the way to exclude just one number. Does that make sense to you? Okay. Now the range. Well, the range happens to be exactly the same, and I want you to think it through. What's the lowest it can go? -infinity. And then it doesn't work at 0, so I got to do the same thing. And it also goes all the way up to +infinity, and yeah, it's going to be exactly the same thing. I'm just going to put the ditto marks here to say same thing. That's what a double mark means. You guys know that? Just means bring it down. Okay. All right. Now, I need to teach you some of the new stuff. And the new stuff, honestly, oh my gosh, this is really important. Okay, it's not the most important thing of the whole year, but this is really important because we're going to go back to this over and over and over and over. Okay. So like when you in Spanish learned how to say hello, hola, right? You probably use that a bajillion times after that to start conversations or to, like somebody walks in the room or whatever. You use it all the time. We use this all the time. What? We use what all the time? We use a transformation of a function all the time. And you got to get really good at it. Okay. So, would you agree fundamentally this is just a x squared thing? Like if I boiled it down, it's an x squared. Do you get that that's a parabola? You remember that that's a parabola? You need to have these memorized. That one's the U-shaped one, right? Okay. Except it's been moved. And would you agree that with a parabola, one could move it left or right or up or down? Okay. Well, this is and instead of saying left and right here, I'm going to start using the more professional word, horizontal. Those are the horizontal changes. Horizontal does mean left and right, okay? And that is the vertical. In Snow White and the Seven Dwarfs, they sing this little song, hi-ho, hi-ho, it's off to work we go. So this is high vo. Why? Because it's horizontal on the inside, with the high, it's high is for inside, horizontal on the inside, and the changes on the outside are vo. They're vertical on the outside. High vo. Get used to that. You're going to use it so often. Because when I change functions, and even if it's a circle, you probably take the center of the circle and you're going to move it right and you're going to move it up. And you got to know how to write that. When you take an absolute value shape like this, the V shape, it can move to the left or right and it can move up and down. It can move horizontally, which is left and right, and it can move vertically, which is up and down. All right. So next thing I want to tell you is that when you make a change, like you move it, there's two kinds. There's kinds that are intuitive. Apple is famous for making intuitive products. Like you can give literally a baby, a toddler, an iPad, and they can probably learn how to open an app and they can probably learn how to play some games. It's so easy to learn. I noticed this with my dad, who is really old. He's in his 80s. And he didn't grow up with like smartphones and all that. But we handed him a iPod. And it was so simple to use that even though he was not into technology or anything, he learned how to use an iPod. And then he learned we downloaded Solitaire onto his phone. And he learned how to play Solitaire. It was just so easy. You touch it, you open it by touching, and you drag things around. And it was intuitive. This stuff is intuitive. This stuff is not. The stuff on the inside is opposite of what you would think. It is counterintuitive on the inside. So I'm going to say it this way. Don't trust the inside. It should feel to you like this moves plus should feel like you move to the right because the positive numbers are over to the right, but it's counterintuitive. And so this goes left 7. It should feel like it goes right 7, and you got to overrule that and go, nope, I don't trust it. It's going to go opposite of what I would think. And would you agree that if I put a multiply by 2 on the inside, that seems like it would get twice as big, and it gets half as big? It's counterintuitive. It does the opposite of what you would think. Now that's as compared to this minus 8 on the outside. That you can trust. That's intuitive. So if I tell you that the minus 8 is going to be either moving up or down, what does it feel like it's going? Down. And you can trust that. It does go down 8. Okay? All right. So I'd like you to just write those two things with this example. This is down 8. High vo is something I'm going to refer to all the time. Horizontal on the inside, vertical on the outside. That way you can carry this over to all those functions, every single one of them. We're going to start with absolute value. And if I just said, y is the absolute value of 4x minus 8, do you think this is 4 times horizontally? No. It's 1/4 as big. Do you think that this is moved left 7? That's what it feels like to me. It's actually right 7. It's the opposite of what you would think. So this one goes right 7. And this one goes down 8, just like you'd expect. All right. What are the other things you can do to it? Well, you can put a negative in the front. Would you agree that that universally means the opposite of? It does. So how do you do the opposite of a drawing? Well, I would ask you this. Is it a high or is it a vo out there? Is that negative? Horizontal on the inside, or is it going to make a vertical change because it's on the outside? High or is it a vo? Talk to the kid next to you if you think it's high or vo. That negative is a vo, which means it's vertical because it's on the outside. You know, the inside is inside of these absolute value bars. That's outside, so we can trust it. So if this is vertical thing, and it's the opposite vertically, what's your gut say about this V shape and what's going to happen to it because I put a negative? It's going to vertically opposite. What do you think that means?
Flip.
Yes, flip. That is the non-scientific way to say it. Technically, it's called a reflection, but I totally would be fine. I understand you when you say flip. It flips over because of the negative. Am I done with this shape? No, I just flipped it over. What else has to happen to it? Where do I have to move it? Right 7. Okay, now I moved it to the right 7 and I flipped it. Now what else? Down 8. That's a fairly long ways down. Do you get why it's generally down there? It's moved right, it's moved down, and it's flipped upside down. Okay. So now that you kind of understand it for an absolute value, and we talked about the quadratics, how about if I do it for the square root graph, which kind of looks like this normally. Remember this guy? Y equals square root x. What if I did this? Minus 1, and then on the outside, plus 4. Which way do you think the graph would move? Say it underneath it in terms of vertical and horizontal. If you want to also include the word left or right, it's fine, but you should say vertical and horizontal on everything you do. The first thing I would do is this. The second thing I would do is this. Use the words vertical, horizontal, and left and right and up and down if you want. I don't even need those. What I really need is vertical and horizontal. Okay. You should have said right, but that's technically horizontal. And I'm fine with an abbreviation of H because I will know what that means. Horizontal, right 1. And vertically, it goes up 4. Make sense? Cool. All right. So let me actually do it. I'm going to move it right 1. Now I'm going to make it blue. There, I just moved my graph to the right 1. And now what should I do to it? So I'm going to take this tail of it, and I'm going to move it up 4. I'm trying to move the whole thing up 4. I know that's not perfect, but do you get my final answer is this one here? It's going to move to the right? No. Okay. All right, I think you're getting this. So, I purposely did something different here. This is not right or left or up or down. What it is, though, is it's either vertical or it's horizontal. Tell the kid next to you what you think it is. It's a vertical. It's a vertical. It's a vertical because why? Because it's on the outside. It's a vote. That's a vertical change, but it's not moving up. Let's investigate it a little further. Here is what a normal V shape looks like. They go at 45-degree angles. That's a normal absolute value graph. What's going to happen is you're going to do a vertical stretch. So if I grabbed this with my hands, imagine this is my thumb and these are my fingers, and I grabbed it with this hand and with this hand, and I grabbed it and I stretched it up. I imagined it's like made out of rubber and it would like stretch. Do you get it would look more like that when it was done? Why did it stay on the bottom? Because I didn't move it up 6. If I wanted to move it up 6, I would have said plus 6. And then it would have stayed the same shape and I would have just moved up 6. This is different. It's a stretch. So if the old value I used to have for y equals whatever it was, now it's going to be 6 times bigger than it used to be. All right, I'm just trying to give you an idea of all the possible things we can do to a function. You don't have to know them all today. The ones you're going to have to do a lot today is left and right and up and down. Okay? But now if I gave you this in theory, you'd be able to tell me, Mr. Server, you flipped it, you stretched it, you moved it to the right 8, and you moved it down 2. I stretched it, I flipped it, I moved it right 8 and down 2. That make sense to you? All right. And then last but not least, if I actually had to graph this, like if I said, it's question number 7 on the test, graph that, you can always go back to the XY chart. I'm going to call it your best friend in graphing. You're going to hear me say that probably 35 times this year. The XY chart, your best friend in graphing. Because I can graph anything with this. Do you get if I get like 6 points, then I get to just graph the 6 points? And if the 6 points look like this, it's going to be like, oh, I guess that's my parabola. That's where it is. You know what I mean? If I got 6 dots, anybody could see where the graph is. So just get a bunch of dots. So how do you get the dots? Well, let's stick in some numbers. You can put in anything you want, but do it the smart way, which is pick numbers that make it really small to start with, because then you're going to end up squaring it and timesing by 4 and all that stuff. So what would be a number I could pick for x that would make it really small? A number you could pick for x that would make it start out small. Well, 1 would give me 1 minus 8 is negative 7, and then I got to go 7 squared is 49, and then I got times 49 by 4. It's going to be huge. 1 is not a good number to start with. Thank you for trying, though. Appreciate the effort. 9 would be a great number to start with, or even 8. Zeros are okay, because 8 minus 8 would have been 0, and that would have been fine. Let's put 9 on our chart. Do you get, as soon as I figure out what 9 gives me, I've got a point. This is one of those first 20 skills. Graphic stuff. All right, so let's stick 9 in, see what you get. Everybody, in your head, go 9 minus 8, square it, times by negative 4, minus 2, and see what you get and put it here. Anybody else get negative 6? All right, I think it's negative 6. All right. Well, if 9 worked, hint, hint, something near 9 also is going to work. Like what? 10. Or what else? 9 and 10 are clearly close together. What else is close to 9? 8. Would you just figure out what 10 and 8 give you? And we'll have at least 3 points. 3 points can tell you a curve. Do you get that 2 points can't tell you where the curve is at all? 2 points make a straight line, but you can't tell if it's curving. 3 points, you can tell where the curve is. All right, so everybody stick in 10, and then stick in 8, and get 2 different answers there. 10 minus 8. I think it's negative 18. Anybody else get negative 18? Yeah. Okay, awesome. Ooh, the 8 is really nice because it just turns a ton of it into 0, and I think you get negative 2. All right. Now, we on purpose pick numbers that work so that you can graph it and get a bunch of points. Like right now, if I take any more numbers, they're going to just get bigger than negative 18, like negative 36 or whatever, and it's going to go off the graph. So I'm going to say those 3 points would be good enough. Okay, so if you take a function that is essentially a parabola, I know that because of this squared thing here. This is basically just x squared, just been moved a lot, and stretched and flipped. And if you can know what all the changes are, and then you can find a few points on them, then you got half of the test already. Day 2. We've already covered half of the things that could be on the test. Now, I know you aren't an expert at it all, but we covered half of your next test already. There'll be little questions like I just asked you. All right. So let's actually start your homework. Everybody find the homework, open it up. And I haven't covered everything, but I covered a lot of it. And when we do hit a problem that I haven't covered, we can talk it through. So I'm glad you're ahead, but can you tell me what number 1 is? Read me number 1.
1 is minus 4 plus x squared. We're supposed to graph it.
Y equals minus 4 plus x squared?
Yeah.
Okay. Now, I want you all to know that this could have been written with a minus 4 this way. Do you get that I like it better that way? Because it makes it feel like, oh, my parabola has been moved down 4. Get what I mean? The minus 4 in front is not illegal, but it's just harder to like understand what's going on that way. So I would change it in my head to look like this. And then I'd go, oh, it's just a parabola. It's been moved down 4. All right, so what's the actual question about it?
Get the domain range.
Domain and range. All right. Well, if it's a parabola, it's been moved down 4. My advice to you is just sketch it. It takes 2 seconds. Parabola moved down 4. That's what it looks like. And then when you ask the domain and range, you're looking at a picture. It's so much easier if you have a picture. So the smart kids on the test make a little sketch. And then they give me the answer. If you just try to think of it, it's so hard to do domain and range. If you're looking at a picture, it's easy. What's the domain? Say it. Negative infinity to infinity. How about the range? Well, you got to ask yourself, how low does it go? And then you think about, oh, I moved it down. How far did I move it down? So then how range is from what to what? Good, and I just made a mistake on purpose. What did I do wrong? Bracket. Nice. Okay, we're cooking. Now, I know we're going to find something that I haven't talked about. I'm just going to pause the video until we get to something. And if you're like, oh my gosh, I have no idea what's going on, and the kid next to you doesn't know either, I'll resume and explain that one last thing. Okay? So go ahead and get a bunch done. And if you guys start talking amongst each other and you're like, hey, you should explain number 6 or whatever, I will.